Alright, let's talk now about the Reductio Ad Absurdum method of doing a proof. I looked for a nifty cartoon or video or something to show at the beginning of this to grab your attention, but nothing grabbed my attention. So if you find one, email it to me. But for now, let's just talk about it, because I know I'm an exciting person to listen to, so anyhow. Alright, let's start with the idea of a modus tollens. You know that if you have P then Q, and you have not Q, you can infer from that not P. Alright, hopefully that's well established in your mind at this point. And let's also get refreshed in your mind the idea of a contradiction. If you remember from when we talked about tautologies and contradictions, you learned that if you have a contradiction, it's always false. Let me use the dot here instead of the ampersand. And it should be clear why it's always false. For a conjunction to be true, both sides have to be true. If P is true, then by definition of negation, it's going to be false on this side. And if not P is true, then P is going to be false. So this can never be such that both sides would be true. Contradictions are never true. They're always false. Okay, so now let's take that idea and look back up into the modus tollens. Let's say we were substituting in here for Q this proposition. Q and not Q. It's a contradiction, right? Okay, what do you notice now? If you have P, then you have Q and not Q. Well, what do you know about this? It's a contradiction, therefore it's always false. If the consequent of your conditional statement is false, well, what do you know about your antecedent? It's also false. So no matter what you substituted in here for P, if it did in fact imply a contradiction, you would know that P is false. So the way that a reductio works is it takes a conclusion that you're trying to reach and it just says, let's assume the opposite. We'll let that stand for C. So, well, let's say the conclusion we're trying to reach is C. What we could say then is, let's just assume that our conclusion is false. If we could show, based on this assumption, that that would imply a contradiction, say it would imply something like G and not G, then we know that our assumption here that not C is false. Well, what's that logically equivalent to? It's logically equivalent to the conclusion. So if we can prove that the opposite of our conclusion is false, then we've just shown that our conclusion is true. I'll do an example of this in the next video, but hopefully this is at least giving you the idea of what's at work behind a reductio ad absurdum and why it does in fact prove that a conclusion would be true if you successfully do a reductio.